We know a complex number z equals a plus bi can be plotted in the Argand diagram. Its distance to the origin is z's modulus. Its argument is theta. From trigonometry, we know a is z's modulus times cosine theta, and b is z's modulus times sine theta. Therefore, z can be written into the polar form, z's modulus times cosine theta plus I sine theta. For example, z is 1 plus I. The modulus is root 2. The argument is inverse tangent 1, which is quarter pi. So the polar form of z is root 2 times cosine quarter pi plus I sine quarter pi. If you calculate the trigonometric values and open the brackets, you can see it's equal to 1 plus I. Let's see what happens to the modulus and argument when you multiply two complex numbers. z1 is z1's modulus times cosine theta 1 plus I sine theta 1. z2 is z2's modulus times cosine theta 2 plus I sine theta 2. z1 times z2 is z1's modulus times z2's modulus, times cosine theta 1 plus I sine theta 1, times cosine theta 2 plus I sine theta 2. Let's open the brackets. It is cosine theta 1 cosine theta 2, plus I cosine theta 1 sine theta 2, plus I sine theta 1 cosine theta 2, minus sine theta 1 sine theta 2. This is cosine theta 1 cosine theta 2 minus sine theta 1 sine theta 2, plus I times sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2. From compound angle formula, we know cosine theta 1 cosine theta 2 minus sine theta 1 sine theta 2 is cosine theta 1 plus theta 2. Sine theta 1 cosine theta 2 plus cosine theta 1 sine theta 2 is sine theta 1 plus theta 2. So the product is z1's modulus times z2's modulus, times cosine theta 1 plus theta 2 plus I sine theta 1 plus theta 2. The modulus of the product is z1's modulus times z2's modulus. The argument of the product is theta 1 plus theta 2. Therefore, when you multiply two complex numbers, you multiply the two moduli, and add the two arguments. Let's look at an example to see how it works. z1 is 1 plus I. z2 is minus 1 minus I. z1 times z2 is minus 1 minus I plus 1, which is minus 2I. Now let's look at their moduli and arguments. z1's modulus is root 2, and argument is quarter pi. z2's modulus is root 2, and argument is minus 3/4 pi. The modulus of z1 times z2 is 2. It is equal to z1's modulus times z2's modulus. z1 times z2 is minus 2I, so it's on the negative imaginary axis. The argument is minus half pi. Arg z1 plus arg z2 is also minus half pi. Therefore, when you multiply two complex numbers, the modulus of the product is the product of the two moduli. The argument of the product is the sum of the two arguments. Let's see what happens when you divide two complex numbers. z1 over z2 is z1's modulus cosine theta 1 plus I sine theta 1, over z2's modulus cosine theta 2 plus I sine theta 2. Multiply the denominators conjugate, cosine theta 2 minus I sine theta 2 on both sides. The denominator becomes cosine square theta 2 plus sine square theta 2, which is 1. The numerator is cosine theta 1 cosine theta 2 minus I cosine theta 1 sine theta 2 plus I sine theta 1 cosine theta 2 plus sine theta 1 sine theta 2. This is cosine theta 1 cosine theta 2 plus sine theta 1 sine theta 2 plus I times sine theta 1 cosine theta 2 minus cosine theta 1 sine theta 2. The real part is cosine theta 1 minus theta 2. The imaginary part is sine theta 1 minus theta 2. So when you divide two complex numbers, you divide their moduli and subtract their arguments. The modulus of z1 over z2 is modulus z1 over modulus z2. The argument of z1 over z2 is arg z1 minus arg z2. When you add or subtract the two arguments, it may be out of the range of minus pi to pi, or 0 to 2 pi. You may need to adjust it to fit the proper range. Z is 2 plus 2i. W is minus 1 plus root 3i. Find the modulus and argument of z squared, z cubed, z squared w squared, and w squared over z cubed. First, let's put z and w into polar form. Z's modulus is 2 root 2, arg z is quarter pi. W's modulus is 2, arg w is pi plus inverse tan minus root 3, which is 2 pi over 3. When we multiply two complex numbers, we multiply their moduli and add their arguments. This is good for A, B, and C. When we divide two complex numbers, we divide their moduli and subtract their arguments. This is good for D. Z squared is z times z. So its modulus should be the square of z's modulus. This is the square of 2 root 2, which is 8. Its argument should be twice the argument of z, which is half pi. Z cubed is z times z times z. So its modulus should be the cube of z's modulus. This is the cube of 2 root 2, which is 16 root 2. Its argument should be 3 times the argument of z, which is 3 pi over 4. The modulus of z squared w squared is the square of z's modulus times the square of w's modulus. This is the square of 2 root 2 times the square of 2, which is 32. The argument is twice arg z plus twice arg w. This is 2 times quarter pi plus 2 times 2/3 pi, which is 11 pi over 6. This is out of the range of minus pi to pi. Let's plot it in the coordinate system. It is pi over 6 below x plus. So the argument is minus 6th pi. The modulus of w squared over z cubed is the square of w's modulus over the cube of z's modulus. This is the square of 2 over the cube of 2 root 2, which is root 2 over 8. The argument is 2 times arg w minus 3 times arg w. This is 2 times 2/3 pi minus 3 times quarter pi, which is 7 pi over 12. In this class, we learned polar form of a complex number is z's modulus times cosine arg z plus I sin arg z. When we multiply two complex numbers, we multiply their moduli and add their arguments. When we divide two complex numbers, we divide their moduli and subtract their arguments. You may need to adjust the argument of the product or quotient to fit in the proper range.